So I'm Steve Young. I'm the Vice President of Business Development and Sales for ICEYE. My role is to look after the global sales for the company. So ICEYE was founded really because there are some issues with what we're doing in the space community at the moment. Using optical satellites, which have been the mainstay for many, many years, you can see what's going on the planet on a fairly regular basis. That's very good, but they can't see at night and they can't see through clouds. So in order to solve that problem, people have been looking at, can you develop a radar system that you could use in space that would enable you to see 24/7, no matter what the weather? Now, why would you need to do that? When you think of things like natural disasters or illegal fishing or any of those other type of global issues that we've got, the ability to be able to monitor those, to map those on a consistent and regular basis is something that's of very high value. They are often a lot quicker to build, they're a lot smaller, they're a lot lighter, so that means launch costs are lower, but also they're much easier to produce than what might be regarded as the traditional satellites, which most of us think of as very, very big, very large, very expensive, sort of government scale activities. So as the satellites have got smaller and smaller, the capabilities have gone up and up, the prices come down and down. We've got to a position where it's economically viable now for a commercial company to build small satellites and launch them and then use those and provide a service from those in a way that used to only be the preserve of governments. The satellites we're producing today are around about the size of a domestic fridge or freezer. 100 kilos, 80 to 100 kilos. So really quite modest, quite small, which means we can then launch more at once, and it also means the costs of building and launching are much, much lower. So really quite small compared to what people are used to. It's easily a factor of 10 cheaper to do the smaller satellites, and it's taken a couple of decades to develop the technology and develop the understanding of how you use existing commercial technology in space. So why does SAR matter, or SAR satellites, why does it matter? It's because it enables you to do things that we've never been able to do before. So we can see at night, we can see through clouds. For example, the Hurricane Dorian that recently happened in the Bahamas, that was a very severe weather event. In order to produce maps for the aid agencies so they could get through, we needed to be able to image through the clouds so we could see the island whilst the event was happening, so we could provide that information to the aid agencies. Without a radar in space, we could not have done that. The next steps for us really, continuing to increase the resolution, so how much fine detail can you see over wider and wider areas. Then how quickly can we get the data to the ground? So can we pass it from satellite to satellite and then to a ground station? Those are the things that are really driving the next level of development. The differentiator for us is absolutely the revisit time. At the moment, you can see a particular place on the planet maybe every 12, 24 hours with what we have. We need to bring that down to the order of 2 or 3 hours. That means you can do applications that you've never been able to do before from space. And that means a whole new set of things that we can deliver to not just governments and companies, but also to individuals if necessary. Oil and gas companies looking at monitoring how much oil and gas is being produced, agriculture companies looking at crop harvesting, insurance companies looking at flood damage, construction companies looking at whether buildings are moving or how construction sites are coming on, and some of the more security type applications like immigration, illegal fishing, ship monitoring. There's such a huge range. What's important for a company like ICEYE is the ability to provide a platform that can really deliver to all of those so that they can consume this data as easily and quickly as possible. What I think it looks like is a regular, reliable and consistent view of what's happening on the surface of the planet. And that view can be updated every hour or two. So you can genuinely see the patterns of what's going on, the changes. change detection, for example, what is happening and where and how fast. How does a radar satellite work? We build and launch a small satellite. It gets launched into an orbit of somewhere between 500 and 600 kilometers above the Earth. It essentially orbits in a polar orbit. That means it's orbiting north-south as the Earth turns beneath it. As it comes over something of interest, there's a radar panel on the satellite which transmits a radar wave, which bounces off the surface of the planet and then is received back by the radar, and then the computer makes sense of that information that's been received back and turns that into an image. So once the data is received on board the satellite, it's stored on the satellite, essentially in a hard disk, until the satellite passes over a ground station, one of those big dishes we all see on the ground, and then the satellite transmits that data back to the ground, and then we can take it and process it and do all the things we want to do with it. Whilst in orbit, the satellite has a design life of around 3 years. The reason for that is, first of all, there's a technology development activity. Every few years, as we all know, the technology develops. We want to make sure that our satellites have the very latest technology on there, but also you have to look at the life cycle of the batteries and the components on board and how many times you can charge and discharge the battery, because it's a battery and solar panel combination that gives the satellite the power. So at some point, those are worn out, just like on our mobile phone, so they have to be replaced. On the financing, the reality for the small satellite world is that the cost of the satellites has been coming down and down over the last decade, as have the launch costs, because we still have to get them there. So we're at a point now where it makes economic sense for a commercial company to design, develop, build, launch and operate its own constellation of satellites. That means more than two working together. We can have enough revenue coming in from the data that we sell from those satellites to enable us to afford to build them and replace them. So it's not necessarily a 3-year business cycle. It's a 3-year refresh cycle for the technology, but there's enough revenue from one of those satellites essentially to pay for itself and then a replacement. So we can close the business case. It makes economic sense now to do this. There is a high technology barrier to entry. It still is rocket science at the end of the day. It still is complicated. This is space, this is satellites. It's not easy. But we have achieved it over the last few years, and we continue to develop the technology to provide this service, this system that everyone can access. I think it's a really, really interesting time to be involved in space and satellites right now, because over the last few years, the technology has got better, the costs have come down, the launch costs have come down. We're at a place where we're beginning to see huge advances and developments in everything that's happening, and the industry is expanding very, very rapidly. It reminds me personally very much of where the aviation industry was in the 1920s, 1930s, and where commercial aviation was really just beginning to take off, pardon the pun. I think we're seeing a similar thing in space and satellite world, in that commercial companies now can make a viable business out of doing this kind of thing. So we're beginning to see almost an explosion in what we would term new space companies coming to the market to deliver something that's never been there before. I think what keeps me up at night is, are we going to be able to get this constellation in orbit of up to 18 satellites? Are we then going to be able to get the ground infrastructure in place quickly enough that can then process all that data and handle all that data, because there's a lot of it, and can we then get it out to people quickly enough so that they can make use of it? Because it's not just about the satellite, it's the whole chain onto the ground, the software, the processing, the storage, the delivery and distribution system. It's all of that which has got to be in place as well as the satellite to make this whole thing work.